Alrighty, good morning everyone. So we'll go ahead and get started here with our first event. And I sort of wanted to just introduce, what this event is all about. Earlier this week, we actually launched this event. It's called Finals Countdown. And the whole point and the whole purpose behind this event that we're hosting here at the Net College Learning Center is to sort of prepare you as students for your final exams. So we sort of designed these workshops and these presentations to sort of bring it back to the very beginning of the semester. So what you see within the Math 100, which is this segment here, is this is the stuff that you've worked on in the beginning of the semester. Then as we progress throughout the next 2 weeks, I believe there's 7 total events for Math 100 specifically. You'll sort of hit all of those portions throughout the entire course of the semester. So you'll be going into algebraic expressions, which is this one, and then tomorrow goes into linear equations and inequalities and so forth. So let me just share my screen here just so you see the schedule. So you have algebraic expressions, linear equations, graphic equations, polynomials at the Math 100 level, and all the way throughout exponential and log functions, which I'm not sure if you guys are working on now currently, but we've sort of designed in that way that you're actually doing these kind of topics throughout the semester. So we're beginning from the very beginning. So hopefully that helps to prepare you in the best way for finals. So that's what this finals countdown is for. So we have 3 different math courses that we're actually targeting at the Learning Center. We have Math 100, Math 110, and Math 102. And then the writing portion is just basically the little things that we have not actually presented on throughout the semester. So we usually default to like MLA, APA formatting and all of that stuff, right? Citations and stuff like that. We've been doing that constantly throughout the semester and previous semesters. So we try to shift them to different topics, basically. So we have like, how to create an abstract or an introduction. If you're doing scientific writing, we have finding a voice, dealing with like tone and mood within your paper, depending on your topic. We have engaging with sources, transitions for coherence, deconstructing the prompt that you're given within a writing assignment. Sometimes we overshadow what the actual prompt is saying and stuff like that. You have speech composition with the rhetorical triangle, unblurring plagiarism, and the art of revision. So all of these presentations are split up among all of our professional tutors. So you'll be seeing different tutors within these presentations. So we also have this gift card giveaway here on the bottom. So if you attend 5 events, you get entered to a drawing, 10 events, and then 15 events. So that's sort of what this finals countdown is all about. So I'll go ahead and hand this over to Terrence. But let me come back a bit. So if you go to our website, you'll find all of the Zoom links and stuff like that in our dclearningcenter.com website. So when you go to upcoming events, you'll see all of our events here with their respective Zoom links, so you can just easily click through it. So I just wanted to introduce you guys to the event that we're actually hosting for the next 2 weeks. So hopefully it'll be super helpful for you. And yeah, so I'll go ahead and hand it over to Terrence, who will go through his presentation. All right, Terrence.
Good morning, everybody. My name is Terrence Leno. I am the professional math tutor here at the Window Rock Center, and my clans are Kiani and Shlitaba Hempasichi, Sitnachani Dashiche, Totsoni Dashanele, and I am going to be covering the introduction to algebraic expressions, and I'll be going over real quickly and briefly as I can, over 5 different topics, which is the introduction to algebraic expression, real numbers, properties of expressions, simplifying expressions, and scientific notation. And in my first example, I'll be giving examples in all these subjects. And in my first portion of algebraic expressions, we're going to be evaluating algebraic expressions. And when we say like evaluating, we're going to be I guess it's like isolating a variable. We could have stuff like x plus 75 or 8xy or 29 minus t and t over or like and a over b. These are just some of the examples. We could have x plus 5 equals 14, and in this expression, they're just asking you to isolate x, find a number that will satisfy this equation. And how we do that is we minus 5, and what you do on one side, you got to do to the other. So we're going to do the same thing to the other side, and we'll have x equals 9. So we're just finding a number that's going to make the statement true. And in other examples involving x, when we're multiplying expressions, we could have stuff like 8 times a, 8 times and these the 8xa, that's in mathematical terms, that's the same thing as 8 times a. So all of these all represent the same thing. They're just written differently. And when we are evaluating, we could evaluate a number like 3y when y equals 6. And all that is saying is, what is 3 times y when y equals 6? And we rewrite that as 3 times 6 equals 18. And also what we could also get is the area of a rectangle when, can you guys see the board? If you can't see the board, let me know and I'll readjust. And we could have the area of a rectangle, A equals length times width, when L equals 24.5 and W equals 16 inches. .5 inches and W equals 16 inches. And all that is saying is we can plug, if we're given a value for our length and width, we can plug that in. And then we just multiply straight across. So we'll have 24.5 times 16 times inches, inches. And then we'll get 392 inches square. And that's just saying that's the area of that whole rectangle. That's why we put the square there, because we're multiplying the inches twice. Any questions? Then our next topic we're going to go over is real numbers. And there's 3 sections when it comes to real numbers. One is called natural numbers, one is called whole numbers, and one is called integers. And sorry about that. I meant to say there's actually going to be one more. It's called rational numbers. And in these ones, natural numbers will consist of everything from 1 to 2, 3, and so forth, all the way to infinity. That's all natural numbers. And whole numbers consist of numbers including 0 to 1, 2, 3, and so forth. Those are all whole numbers. And integers consist of everything that's lower than 0, from like negative, let's start from -2, -1, 0, 1, 2, 3, and so forth. And those are all integers. And our rational numbers, those are including everything else from fractions to decimals, like 2/3, -2/3, 4, 3, 0, -23/8, -2.4, 0.17, and 10 and 1/2, and so forth. Those are called rational numbers. And rational numbers, they can be anything, like we could have A represent any number on the on any number in our number table, in our number line, over B. And that's going to be equal to -A over B is going to be equal to -A equals A over -B. When B is not equal to 0, because that'll make it undefined. And when it comes to our rational numbers, we can convert rational numbers to decimals. Like we could have 1/2 here, and if we were to convert it, we would divide it, have our denominator on the outside, and we're going to divide it by our numerator. 2 cannot go into 1, so we're going to have to add a decimal. and a 0 here. 5, 10. So that's when you convert fractions to decimals. So 1/2 is going to be equal to 0.5. And negative 1/2 is going to be equal to negative 0.5. Any questions? Okay, I'll be moving on to properties of expressions. We have for any number a plus 0 equals 0 plus a equals 0. That's if we were to throw any type of number in for a, it's gonna still come out the same. They're all gonna balance out, and that works the same way with when we're multiplying our expressions. It's gonna look like a times 1 equals 1 times a equals a. And then, so what I'm going to be going over, or the examples I'm going to be giving, is going to be in the fraction term. My first example is going to be negative 20x divided by 12x. We're going to separate, kind of break it into two multiplication examples that could be equal to 20x, and we can rewrite it as 5 times 4x over 3 times 4x, negative. And then this, when we break it up like this, there can be some cancellations, not cancellations, but numbers that could divide each other out. We have 4x over 4x equals 1. So we could rewrite that. So this will come out as 5 times 1 over 3 times 1, which is going to equal 5/3 negative. Carry your negative because that can change your whole, that just makes the big difference if you forget your negative. So that's one example. My next example is I'm going to use as 14ab over 56ab. And then the 56, we can break that up into 14 A times 4B over, or 14A times B over 14A times 4B. Then this one, we can cancel these two out, make them 1, and then we'll be left with B over 4B. Any questions?
Did you, is there a way that you can actually simplify that even more?
Yeah.
Okay.
This one?
Yeah.
Yeah. The B's, the B's will cancel out also. We could have B over B times 1 over 4, which is going to equal 1/4. Any other questions? Our next topic we're going to cover is simplifying expressions. And we're going to be using the property of -1. We could have -1 times A for any number is going to equal -A. Then that's a property when we're given a problem like this, 3 times. And when we're given a problem just like this with parentheses, what we're going to do here is we're going to FOIL it, because there's always this invisible -1, and we're going to apply -1 to both of these. And this is where you got to be familiar with the laws of multiplication of positive times positive equals positive, negative times negative equals positive, negative times positive equals a negative, and a positive times a negative equals a negative. Opposites. So we're going to apply that here, and we're going to distribute that -1. So we're going to have -3 minus x. And that's as far as you can only go with that, unless you're given a value for x, and then in that case we would have to work with our parentheses first. And in my second example, we could be given a problem like 3x minus 4x plus 2. And in that case, we could rewrite that as 3x bracket minus 4x plus 2. And then we're going to FOIL, or not FOIL, distribute this negative to this parentheses, and we're going to be left with negative 4x minus 2, 3x. Sorry, I made a mistake. There was supposed to be a positive here, 3x, because we're not multiplying that. And then, after we do that, we can redistribute this positive into the parentheses, which is going to give us 3x minus 4x minus 2. And then from here, we combine our like terms. When we're adding a negative to a positive, it's like subtracting. But when you have if your negative number is bigger than your positive number, then it's going to keep that sign. So we're going to have negative 1x minus 2, or negative x minus 2. Both of them are the same. They both represent the same thing. And any questions with this one? In our next example I have, we could be given a problem like 2 bracket 3 minus 7 plus 3 bracket, which is going to equal we work from, when it comes to like the order of ops, we work from the inside out, the brackets that are the 7 and the 3, we're going to work with that one first. So it's going to equal 2, 3 minus 10 unbracket. And then from there, we can rewrite this as 3 minus 10, and then keep our parentheses 2. And if we combine or subtract this equation, we're going to get negative 7 times 2. And the law of multiplication opposites is going to be a negative, and we're going to be left with negative 14. And that is going to be our answer for this equation. And in our next, my next example that I'm going to give, you could be given a problem like 25 divided by 5 plus 50 divided by -2. We do our, we always work from your first is multiplication and division, but you work from left to right. And then we do our addition and subtraction in the same way from left to right. But those, it's, I think we'll be going over that in time tomorrow, I believe. So when we have 25 divided by 5, that's going to give us 5. Plus -25. And then a positive times a negative, that's going to keep the negative, and we're going to be left with -25. 5. Bring down our 5. So this will be 5 minus 25, and we're going to be left with -20. Because we're going to be subtracting 5 from -25, or adding 5 to -25. Any questions? Oh. All right, moving on. Scientific notation. I believe we're all familiar, where m can equal any number times 10, where n your power, where n can represent any number. But how to convert numbers into scientific notation, we have to have 1 has to be less than or equal to your m, which is going to be less than or equal to 10. And if you don't understand what I mean by that, here's an example. We could be given 7,800 or 7,800, 78,000. Sorry about that. And we could convert this number into scientific notation. Right here is where our decimal is at, and we could move it 1, 2, 4 decimal places to have our m less than 10, and we moved it 4 spaces, and that's where your n is going to be coming in. So it's going to look like 7.8 times 10. How many spaces we moved over? 4. And that is an example of a scientific notation. And it could also work in the opposite direction. We could also be given 0.0 or 0.000050 or 57. We could convert that into scientific notation. We could be do the same thing, move our decimal space up to here, 1, And then that will be 5.7 times 10, but it's not going to be a positive. We're moving into the opposite direction, which is going to make this a negative 5. And then that's in the other direction of converting to scientific notation. And then what I wanted to go over was multiplying scientific notation and dividing scientific notation. When we're multiplying scientific notation, we could be given a problem like 4 times 10 to the 10 squared times 2 . When we're multiplying scientific notation, we take only in scientific notation this will work. We take our first two numbers, 4 and 2. We can multiply that 4 times 2 times 10 squared 10 cubed. Then our new equation, 4 times 2, 8 times 10. And when you're multiplying power exponents, you're just going to add these two together. Your 2 and your 3 plus, that's going to be 5. And that is one example of multiplying scientific notations. And that works the same way when you're given a notation that is in a decimal form, which is going to be, one example could be 1.8 times 10 to the 6 times 2.3 times 10 minus 4 to the negative 4. And within this notation, we can execute it the same way we did at the top. 1.8 times 2. Take your power, your 10 to the 6 here, multiply that by your 10 to the negative 4. Oops. 2.3. So 1.8 times 2.3, we get 4.14 times, and within this equation, we have 6 minus 4, so we're just going to subtract 6 from 4, 4 from 6, and we're going to be left with times 10 squared. And that's how scientific notation works when you're multiplying. And the next one I wanted, any questions with this?
Can you, oh, never mind. Sorry.
What did I do, Kwana? Sir?
I wanted to come back to my screen froze for a bit, so I didn't know you were erasing it, but I wanted to come back to I think you had like 8 times 10 raised to the something. I wanted to know how you got from the 8 down to the 1.4 and the 2.3.
I think that they were both different. They were both different examples, different expressions. How I got from the 8 was I multiplied 4 times 10 squared times 2 times 10 cubed. And did you want me to redo it?
Okay, I got it. Never mind. It's okay. I got it. I got clarification.
Okay. The next part, the last part I want to go over is dividing scientific notation. We could be given an example of 8 times 10 to the 5th. Divide that by 4 times 10 squared. Another way to write this would be 8 times 10 to the 5th over 4x, 4 times 10 squared. And then from here, you can separate them. What? 8 divided by 4 times 10 to the 5th divided by 10 squared. And this will equal 2 times 10. And when we're dividing our exponents, we're going to do the opposite of how we did the multiplication. We're going to, in the multiplication of scientific notation, we added. But when we're dividing scientific note, these exponents, we're going to subtract. So it's going to look like 10 minus 2 here. Or I should rewrite that over here. 5 minus 2, which is going to equal 2 times 10 cubed. And we can also be given a decimal scientific notation to divide out also. An example, we could be given like 6.4 times 10 minus 7 to the negative 7. Divide that by 8.0 times 10 to the 6. We can write that in the same expression as we did as the top. It can be written as 6.4 over 8.0 times 10 minus 7 over 10 to the 6. And when we divide 6.4 divided by 8.0, that's going to give us 0.8. And we can carry over this times 10 minus 7, and just it works the same way. We have to subtract. So this 6 is going to turn, this positive 6 is going to turn to a negative 6. So it's going to be 7 minus 6 in our exponent. And our final answer is going to be 0.8 times 10 minus to the negative 13. And then that would conclude our final answer. Any questions? Oh, shoot.
All right. Do we have any questions? Is that it, Terrence?
Yeah.
All right, cool. So I'm going to have Audrey, she's going to put out an evaluation form for you guys to fill out. And that evaluation form is actually how we're going to be tracking, this gift card giveaway that we're hosting. So if you guys seen the flyer, you see that there is a gift card giveaway. So your attendance actually, as many times you attend any events like within the next few weeks, you'll be added to a drawing if you attend 5 events. If you attend 10 events, you get entered to another drawing for $50. If you attend 15 events, you automatically get entered into a drawing for a $100 gift card. So all of that information is on the flyer. And if you guys want to, you can visit our website at dclearningcenter.com just to keep yourself updated with all of the events and stuff like that. So what you see on the screen here is dclearningcenter.com. So if you go here, you can go to upcoming events, and you'll see all of the upcoming events that are hosted by us throughout the month of April, and then throughout the upcoming months and stuff like that. So we're pretty much done with algebraic expressions here. So if you want to see the flyer, you'll see them here. So this is the part where it's crucial for you to actually fill out that evaluation form. It does ask you for your initials, which is how we're going to keep track of who attended the event and then who turned in the evaluation. So if you turn those in right away, and we jot those down, we see how many events you attended, we'll go ahead and enter you into those drawings if you meet the 5 or the 10 or the 15. So the drawing won't probably happen until after the event is done, so probably on the 30th next week. So just so here are some upcoming events that are happening. So today we actually have whole numbers for Math 102. I'm not sure if you guys are going to attend that portion, but that's for the Math 102 students. And then we also have abstracts and introductions, which Zandria will be hosting that one. She'll be going over learning how to break down, evaluate, and construct the proper introduction and abstract for those of you that are enrolled in science courses or within English courses. So how do you create that introduction, and things like that. So she'll be going over that portion. But I just wanted to explain the evaluation portion really quickly before I let you guys go. So I want to thank you guys so much for attending the first presentation of our finals countdown event hosted by the Learning Center. And yeah, I hope you guys enjoyed it, and I hope you guys come to our future workshops that we'll be hosting throughout the whole 2 weeks. So thank you again, Terrence. Yeah.
Yep. Thank you guys for showing up.
Yeah, make sure you copy the link. Again, that's a crucial link that you'll need to be entered into the gift card drawing. And then a lot of these videos I actually am live streaming them on Facebook. And then immediately after I end this, I'll be posting on our YouTube channel if you want to come back to the videos and stuff like that. I'll be doing that to every single video throughout the next 2 weeks. So yeah, thank you guys.